Digital differential analyzer. As the name itself says, the difference is analyzed in a digital medium. Yes, absolutely, it is fast, accurate and more efficient compared to our DDA algorithm. Over here we can note there are various lines that can be drawn or considered by using this Bressenham CAD software. So this algorithm is used in CAD software to display solid engineering and architectural models. Hello everyone, I welcome you all to the second session of Unit 1, that's under Computer Graphics and Multimedia. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor in the Department of Computer Science, Vidhyaashram, Temple of Excellence, MYSURU. First unit is all about understanding the basics of computer graphics. Yeah, so the unit name is Computer Graphics Fundamentals. So let's move forward and see like what are the things that we have discussed in our previous session. So in our previous session, we did discuss like what is a computer graphics. Then we did discuss the applications of computer graphics. Up next, we did also discuss the video display devices as well as the overview of computer graphics. Then we discussed the simple monitor comparisons, like what are the different kinds of monitor that are present and what is the present monitor type that we will be using and utilizing in order to work with computer graphics. So we have discussed this in our previous session, and apart from that we did discuss the types of scans that is available and what is the type of scan that we use in our day-to-day life is also being discussed in our previous session. Then a simple difference between a graphics monitor as well as a workstation and what it is, where is it used. So these are the things that we have discussed in our previous session. And last but not the least, we did discuss what is a point and a line and how to represent it in a form of a graphic. So these are the things that we covered in our session 1. All right. So let's move forward and see like what's the agenda of today's session. This session uniquely covers various types of algorithm that supports the computer graphics like line drawing algorithm, midpoint circle, ellipse, scan line polygon, then the boundary fill, flat fill. Up next, we do also discussed how to represent a curve, then various types of parametric curves, then the parametric representation of a circle as well as a cubic curve and a Bezier curve are all discussed in our today's session. So let's get started with today's session with a simple line drawing algorithm. So this is a very basic kind of algorithm where we will see the points in order to draw a single line. Okay, so now let's see what is the purpose of this line drawing algorithm. The main purpose is to draw a straight line efficiently. Okay, then what are the different algorithms that is been utilized in order to draw a straight line? Yes, we have two different algorithms. The first one is DDA algorithm and the second one is Bressenham algorithm. So you can see here we are representing our required points by using a simple line. So this is with respect to a line drawing algorithm. Now let's see the first type, that is DDA algorithm. DDA in the sense digital differential analyzer. As the name itself says, the difference in the analyzer is carried in a digital way. So you can see here we have a first point that is x1 comma y1, and until we get a second point that is x2 comma y2, that portions are considered as differential analyzer, or there is a difference between these portions, that is a colored portion, and the remaining portions. So this is what our digital differential analyzer. Now what are the steps in order to find this line? So we have specific steps for that. So the first step is calculate dx. Okay, we are calculating the differential value with respect to point x. Similarly, we need to calculate the differential values with respect to point y. Next, we need to find what are the total number of steps that are required in order to draw a line. Okay, the next step is to increment x and y. As we increment, we get 2 points. So 2 points are sufficient to draw a line, correct? So what's the next step? The next step is to plot the pixels. Up next, we have a simple formula. So the formula with respect to x is x plus differential x, or any change in a value of x is considered together to find x. Similarly, with respect to y, it gives y plus delta y, in the sense y, okay, that's a particular value and delta y is the differential value, or the variable change in the y is considered as delta y. So this is with respect to DDA algorithm. What is DDA? Yes, exactly, it is digital differential analyzer. So now let's go with the next type, that is Bressenham line algorithm. So what is this Bressenham? So it uses an integer arithmetic in order to draw the lines, and it is faster compared to our previous line drawing algorithm, that is digital differential analyzer. So which is most fastest under line drawing algorithm? Our Bressenham algorithm is more fastest. Now let's see what are the advantages of this. Yes, absolutely, it is fast, accurate and more efficient compared to our DDA algorithm. Over here we can note there are various lines that can be drawn or considered by using this Bressenham. But the main point to note here is all the lines which are in our black portions represent a line. So we can draw multiple lines by using Bressenham algorithm. So now let's go forward with the next type of algorithm, that is midpoint circle algorithm. The main purpose of this algorithm stands to draw a circle efficiently. So we saw the line drawing algorithms. Now we are seeing the algorithms that is utilized to draw a circle. Now, what are the uses of this midpoint circle algorithm? What is the use of drawing a circle? As we know, we need circle in printing or designing logos, designing the updated wheel technologies, as well as in a software field also, like if you are designing the UI buttons. So those buttons will also be in a circular form, isn't it? So that's why this circle, midpoint circle algorithm is mainly utilized for these things. And it can draw a circle efficiently. So over here we can see we will point various positions in the XY plane, so that by joining those positions we can get a efficient circle. All right, so this is a midpoint circle. Why this is midpoint circle? Because the angle that is considered from the center will be a 45-degree angle, and all these points, okay, all these points are considered from the center part only. All right, now we did saw the line drawing algorithm, circle drawing algorithm. Now next, what if we have other shapes other than line and the circle? So other shapes are altogether considered as a polygon, isn't it? So now let's see what are the different polygon filling algorithms that are available. The objective of this algorithm is to fill the inside region of a polygon. So now we have three different types of algorithms with respect to this. So let's see what is that. The first one is scan line fill algorithm. And what is the description of this algorithm? It fills the polygon by scanning one horizontal line at a time between its boundary intersections. Between its boundary intersections. Very, very important. Okay, so this is with respect to scan line fill. Next, second one is boundary fill algorithm. So it starts from a seed point. Okay, seed point in the sense the main initial point will be considered as a seed point, and the filling will start from that seed point and it fills the area until what? Until it reaches the specified boundary color. Okay, so that is the boundary fill algorithm. Next, third one is our flood fill algorithm. Even here it starts from a seed point and it fills all the connected pixels or the points, okay, having the same target color. If a pixel is having same target color, then that pixels are also considered together and are filled considering it has a polygon. So these are the three main different kinds of polygon filling algorithms, starting with scan line fill algorithm, then boundary fill, as well as flood fill. So now let's see one by one what are this and how it works. So let's get started with first one is scan line polygon fill algorithm. So as we know, it fills a polygon by drawing horizontal scan lines between the pair of boundary intersections. So over here, let's say an example, we have considered this polygon. Okay. Now, how this is filled by a scan line. So you can see here, we have one scan line. So these and these are the intersection points, correct? So in between that intersection points, we are drawing the horizontal scan lines. Now let's see the working of this algorithm. The first step under it is it scans the polygon one horizontal line at a time. Okay, that's the first step. Next one, it finds we need to find the intersection point of the scan line with the polygon edges. Okay, scan line with the polygon edges. Third point, we need to sort the intersection point from left to right. What is the thing? We need to scan from left to right. All right, next one, it starts with the filling. So fill the pixels between each pair of intersection. All right. Next, finally, we need to repeat until all the scan lines are processed in a same way. So this is our very simple scan line polygon fill algorithm. Okay. So let's move with the next one. Before that, let's quickly see what are the advantages and applications of this. Advantages is it is very efficient for filling large polygons. Next, the second one, it is utilized to produce uniform and accurately filled regions. Most importantly, these are used in computer graphics in order to do the rendering process. Next, let's see the applications. First application is in computer graphics. As we know, it is utilized in rendering 2D and 3D objects. The second application is in CAD software. So this algorithm is used in CAD software to display solid engineering and architectural models. Next, the third one is in game development. It is utilized to render the shapes as well as the gaming environment efficiently. So these are the various applications. What are the applications? It starts with a simple computer graphics. It is also used in a CAD software as well as in a game development. Let's move forward with our boundary fill algorithm. Boundary fill is utilized to fill the enclosed region by starting from a seed point and continuing until it reaches the boundary colors. So now we can see here we have a boundary color and we do have a simple seed point. So now it starts from a seed point and it will be continuing until it reaches that boundary color. All right, let's see the working of this. The first point is to select a seed point inside the polygon. Okay, that's the initial thing. Next point is to check whether the current pixel is not the boundary or fill color. Okay, we need to verify it and then fill the color. The next step is to fill current pixel with the desired color that is according to our requirement. Next one is to repeat the process for the neighboring pixels as well. So through this, we can expect a 4 connected or 8 connected model. So these are the standard models. Clear? So this is our fourth step. Next, fifth step is to stop when the boundary color is reached. So this is a complete working and very important with respect to exams. So just start with a point, explain it in depth with a good description. So let's see the advantages. So the boundary fill is very simple and easy to implement, and it is most oftenly used to fill the enclosed regions with a noun boundary. Okay. Next is this supports both the 4 connected as well as 8 connected models. Now with respect to the applications, it is used in a simple paint software that we used to do in our Windows systems, and it is also used in the drawing applications. Up next, it is also considered in image editing. So these are the various applications. Let's move forward with the next algorithm, that is flood fill algorithm. The flood fill algorithm is a classic technique, okay, which is used in computer graphics as well as in image processing in order to identify and change a connected region of pixels in a multi-dimensional array. For example, in a 2D grid, or so over here this is also considered flood fill. So how it works, let's see here. We have a comparison between a simple boundary fill as well as a flood fill algorithm. So now let's have a flood fill algorithm first. We can see here the floods are completed for connected model. Now with respect to this, we have a fill completed, that's by a green color, and next inside the polygon it has been filled. In a basic way, let me tell you, flood fill algorithm in the sense complete pixel will be filled either in a same color or in a different color depending on the utilization. And in the boundary fill, what happens, it just fills the boundaries by seeing the pixel. Okay, so this is a boundary fill and a flood fill, a difference between these two things. Let's move forward and understand a curve representation. Curve representation, it just means that representing a curve with respect to mathematical factors. So in order to do this, we have various types of curve representation, starting with the first one, parametric curves. As the name itself says that there will be a parameter, and with respect to that parameter, we will be defining various variables. Thus, we are considering x and y coordinates depending on the parameter t. So, this is a special parameter, thus it is considered as a parametric curve. The next is a cubic curve. A smooth curve which is used to represent, or it is represented by a third degree, or we can say that cubic polynomial equation for precise shape control. So that's the next one. The third one, very important, that is Bezier curves. Even Bezier curve is a smooth curve and it is generated using control points. So very important. So the keyword for this Bezier curve is the control point, and it is widely used in our computer graphics, animations, as well as in a font designing techniques. So these are the various types of curve representation. So what are those? First one is parametric curve, where the x and y coordinates are dependent on the parameter t. Next one is our cubic curve. Even here it goes with a smooth curve, where we will be utilizing the mathematical factors in order to make a 3-degree or cubic polynomial equations in order to control the shape. Okay, the next one is a Bezier curve. Even here this forms a smooth curve, but by utilizing control points. Okay, so these are the 3 various curves. Over here we have a small parametric representation where the first parameter is considered as P0, then our P1 parameters are there, both are same. Why? Because the parameter is considered at the same point. So P0, P1 as well as P3. Where is P2 parameter? It lies somewhere here. Okay, so where the continuation goes. So let's move forward with parametric representation. So we know that the coordinates are completely dependent on a parameter t, correct? So over here the x coordinate is been defined by f of t. Similarly, y is defined by g of t. And let's consider an example. In order to draw a circle, we will define x as r cos t and the y has r sin t. So over here we can see the parametric representation of a circle through our x and y values. Up next is our parametric representation, that is the second representation. What is that? The cubic curve. So these are the industrial standards in order to model smooth shapes and animation parts in computer graphics, and they offer lowest polynomial in order to draw a shape. So the various parametric curve that can be represented are: circle can be drawn, ellipse, then a simple parabola can be considered, as well as a hyperbola can also be considered. So let's move with the next one. Yes, next one is all about our Bezier curve. As we know, with respect to this curve, there lies a control points, right? And because of this control points, this has a wide level of applications. For example, it is used in Photoshop in order to create smooth paths as well as selection and vector based shapes, and it is also used as an illustrator, which is used to design scalable vector graphics, logos, as well as illustrations. Next one is in animation. It is used in animation in order to create smooth motion paths and realistic object movements. Next, it can also be used in creation of font designs, where it is utilized to define the smooth outlines of character for a high quality digital fonts. So this is with respect to the Bezier curve. So this is completely with respect to unit 1, where we have discussed almost various kinds of algorithms, that starting from a point, then a line, then a circle, as well as next is a polygon. So we have discussed multiple algorithms. So these algorithms are very, very important with respect to exam point of view. So this was with respect to the unit 1. So thank you